Hello guys, welcome back to Centennial College Maths Drop-in Center. Today we'll be looking at some of the questions related to simplifying of trigonometric expressions, and let's take a look at first question. So the first question we'll be solving together would be sine theta tangent theta times cosecant theta plus cot theta. Alright, so let's recall the basics first. So we have 6 trig functions: sine, cos, tan, cosecant, secant, and cotangent. Right? Sine is opposite over hypotenuse, cos is adjacent over hypotenuse, tangent is opposite over adjacent. People like to remember it with SOHCAHTOA, which goes like this. And the main thing to remember here is that cosecant theta can also be written as 1 over sine theta. Similarly, secant theta can be written as 1 over cos theta, and cotangent theta can be written as 1 over tangent theta. Sometimes it would be useful to write it as sine theta over cos theta. Can you guess what cotangent theta would be written as? Yeah, so cotangent can be written as cos theta over sine theta. So let's take a look at the question again. We'll first just multiply. So cosecant theta and cot theta are in bracket, so we'll multiply sine theta tangent theta with cosecant theta first, and then there's addition sign, and then we'll multiply it with cotangent theta or cot theta. Sine theta tangent theta cot theta. Cosecant and sine are multiplied together, and we know that cosecant is opposite of sine. So what I can write cosecant as is sine theta times tangent theta times 1 over sine theta. Why I did this? To simplify it further. So now you can see that sine theta can be cancelled out, and similarly over here tangent and cot are opposite of each other, right? So I can write it as sine theta times tangent theta times 1 over tangent theta, and now tangent theta get cancelled. What we are left with is tangent theta plus sine theta, and that's it. We can simplify it. We can't simplify it further, so we'll just leave it here. Alright, so question number 2. Let's try simplifying cosec x over tangent x plus cot x. Alright, so what we have here is everything is in form of cosecant, tangent, and cot, right? So it would be just easier for us to convert everything into the form of sine and cos. Sine and cos are some of our basic functions. Sine and cos are basic functions. Why I call them basic function is because all other functions can be written in form of sine and cos. So right now in this question, what we can do right now without converting them is write this. Write cot x as 1 over tangent x, right? And we can take the LCM. So these two would multiply together. We'll be left with tangent square x plus 1 divided by, at this point a lot of students get confused. So now if you get confused at this point, you can try this step. So try writing it as this. So cosecant x is divided by tangent square x plus 1 over tangent x. And if I change the division sign into multiplication, this term would flip. So tangent would go on the top and the top portion would come in the bottom. So like the numerator and denominator would exchange places. So I would have cosec x times tangent x over tangent square x plus 1. Now at this point we are stuck. We can't solve any further. So what we can try and do is convert everything into the form of sine and cos. Remember, those are the basic functions. So I can write cosec x as 1 over sine x, and I can write tangent x as sine x over cos x. Sine x over cos x. And tangent square x can again be written as sine square x over cos square x plus 1. Sine would cancel out. We'll be left with 1 over cos x over sine square x plus cos square x divided by cos square x. Just a recall point, sine square x plus cos square x is actually 1. So I can write it as 1 divided by cos x divided by 1 divided by cos square x. Right? So just to simplify it, I'll write 1 over cos x, division sign, 1 over cos square x. And I now convert this division sign into multiplication. We have 1 over cos x times cos square x. This would cancel out and we are just left with cos x. And that's it.